this video, we will review the different round types that you have available in the Open Autonomy framework that you can use to build your autonomous service. Remember that an autonomous service built with the Open Autonomy framework is structured as a finite state machine. This finite state machine may contain a different set of states with a different set of transitions, and it is encoded in what is known as the FSM map. Each of those states is implemented using a number of objects, namely the behaviors which execute the proactive actions, the rounds which cast the appropriate events following the behavior execution, that is, the rounds understand what has happened in this state and cast the appropriate events, and finally the payloads which contain the information exchanged between agents in the current state. The framework comes with a number of convenient predefined rounds which are useful for many situations when you are defining your autonomous service. So these are available as base classes in the framework in this location, packages.valory.skill.abstract_round_abci.base, and they can be extended with custom post-processing logic. So the idea is that in most situations you don't need to extend these rounds with custom logic, but you have the option to do that if you need for the particularities of your service. The first rounds that we are going to present are the rounds that wait until all agents have responded. You can identify these rounds because they end with until all. So we have two rounds of this type, one which is collect same until all, which collects the same payload from the agents until all of them have responded, and the other one is collect different until all, which collects different payloads from the agents until all agents in the service have responded. So these rounds are actually not recommended to be used in the general case on your autonomous service. So those rounds have a very specific and limited usage, and we recommend that you use some of the rounds that we will discuss in the next slides. The next set of rounds that we are reviewing are rounds that wait until a threshold of agents have responded. That is, they don't need to wait until all of the agents have responded. This threshold is typically set to 2/3 of the number of agents composing the service. So the reasoning for this is that the service could have some sort of malicious agent, some agent not following the protocol, or some agent that is down or not responding for any reason, like for example network congestion. So in this case, the service logic, the business logic, will still be able to process as long as a threshold of agents have responded in this particular state. So we have three in this category. So one of them is collect same until threshold, which is a round which expects the same payload from all the agents. So for example, this could be some sort of local computation or local processing of some information that it expected that all the agents agree on the same output value. Collect different until threshold, this expects different payloads from all the agents, again until a threshold of them have responded. And this can be, for example, a round used in a price oracle where the different agents collect information from different sources, and of course they are not going to get the exact same quote for a given price. And the final one in this category is collect non-empty until threshold, which is a special round. It's used in some sort of specific situations. You can also use it in your services. And this round collects different payloads from agents, keeping only non-empty attributes until again a threshold have responded. So again, this is like a very specific use case, but you can also use if you find it useful. Finally, we have these 3 rounds which are used for specific situations. So the only keeper sends round is a round in which only the keeper is expected to send a payload, because it's only expected that one of the agents is in charge of executing some sort of action. So this could be, for example, submitting some sort of transaction on-chain, or executing some sort of contract call, or accessing some API which has restrictions or is a paid API, and we only want that one of the agents of the service, which is called the keeper, executes this action. Before executing this action in a round that is only keeper sends round, we need to select the keeper. So this has to be selected in a previous state, and it will be using an collect same until threshold round typically. So the next round that we have is the voting round, which collects true or false vote from all agents until a threshold has been reached. And the idea of this round here, you can think of as a branching or as a conditional state in the finite state machine, meaning that if the agents evaluate that some condition is true, it will branch on one side of the finite state machine. If the agents determine that this condition is false, it will branch to other path in this FSM app. Finally, we have the generate round, which is a round which is just a placeholder for final states. This is useful when we want to chain a given finite state machine with another finite state machine. So the generate rounds is the placeholder for the rounds that will allow us to do this transition from one finite state machine to another finite state machine. So there's no action executed and no logic executed in these rounds. So now let's see how this is used in existing services. So let's take the Hello World and the Trader service, and let's take a look on how these rounds are used here. So, for example, in the Hello World service, we have a round which is called collect randomness round. So this round is essentially used when agents contact the centralized randomness service, and they collect the same randomness from this service. So for this reason, this round has to be a collect same until threshold round, because all agents will be collecting the same randomness. So as you can see, when I'm using this class here, I just need to define a number of attributes for the parent class, which are the payload class, which in this case is collect randomness payload. If we examine this class, we can see that the contents is just like the round ID and the randomness which is collected. So the other attribute that we need to define when we extend this collect same until threshold round is the synchronized data class, which in this case we are calling it simply synchronized data. And we need to define 2 events that will be casted. In this case, one will be like the done event, when we have a threshold of agents and they have provided contents for this response. And we have a special event which is called the non-event, which is emitted when a majority of agents vote, but the vote only has empty attributes. In this case, we emit the event none. So this can be used to check some sort of error conditions when we don't want to add any extra logic. So we can just simply return a non-attribute for this payload, and this event will be emitted. So we also need to define which is the event that will be emitted when there's no majority, which is that agents don't agree on a majority value to be chosen. And we need these two special attributes here, which is the collection key and the selection key. So the collection key, it's a mapping. It's the name of the mapping from the synchronized data, where the application will be storing the participant address to the randomness that it has selected. In this case, we have defined for the synchronized data this attribute here, which is a mapping between a participant address and the randomness provided by them. And we are using this function just to retrieve the name of this attribute. So the selection key is the name of the attribute of the synchronized data that we want to store. So in this case, whichever will be the majority vote selected will be stored in this attribute, which is called most voted randomness. So if I have several attributes, there's a way of specifying what is the how they will be stored in the synchronized data. We will see this in an example of another round. So if we go to, for example, this tool selection round, which is a round from the trader, which is a more complex service. So in this case, we see that the structure of these attributes follows more or less the same pattern. But in this case, the selection key contains several attributes. So this means that I will be storing this in this synchronized data attribute, the available MEC tools, in the policy and utilized tools, and on the MEC tool IDX. So how are these collected, these values? So those are collected from the most voted payload. Since we are in a collect same until threshold, in this case, if I go, for example, to the associated payload, to this, here we have this the attributes that will be associated to the synchronized data. So the way this is collected is by order where it is defined. So in this case, for example, let's assume that the payload is that agents are sending some values on this payload, on this attribute of the payload, which is the policy. So this will be stored in the second value of this tuple. In this case, I'm going to store it in the synchronized data attribute called policy. So this function getName, it just returns the name of this. In this case, it will be policy. So here I am defining a tuple that has to match with the values that I want to store from this most voted payload. In this case will be the MEC tools, the policy, utilized tools, and the index. So now if we examine another round from the trader service, which is the decision receive round. This round, as you can see, it follows the same structure. It defines the done event, the non-event, the non-majority event, and the selection key, which is in order the name of the synchronized data attributes that I need to store the payload, the most voted payload in this case, the attributes of the most voted payload. The collection key again, it's simply a mapping between the participant addresses, the agent addresses, and the payload and the associated payload. However, in this class, we need some sort of post-processing, of additional processing. So this is the case of rounds that need to return additional events, need to do some sort of more complex transitions. And to do this, what we need to do is to override the endBlock method. So the recommended way of doing this is first call like the superclass endBlock. This will return a result. And then we pass this result into the synchronized data returned by this superclass, and the event return in theory by this superclass. So again, the events by the superclass will be the done event if all agents have provided some sort of input to this payload, and the non-event if the most voted payload only contains empty attributes. So after processing this, I can do some sort of additional processing. So for example, in this case, I am comparing if the event is event done by the superclass, and some sort of attribute in the synchronized data is known, in this case an attribute which is called vote. So I cast another event. In this case it's event tie. So here I am also doing some sort of post-processing again, and in this case I'm casting event unprofitable. And in this other post-processing, so I'm casting this benchmarking finished event. So again, this allows to have some sort of flexibility on the number of events that can be returned from a given state, which is processed by this round. So if we examine another round from the trader service, in this case it's called check stop trading round. In this round, what the service is doing, it's evaluating a condition. If this condition is true, the service will stop trading. If it's false, it will continue trading. So this is precisely what voting rounds are about. It's like an if statement for a service. You can think in these terms. It's a branching point where two different branches can happen depending on a given condition. So the condition is not important at this point. You just need to know that it's a condition that can be evaluated to either true or false. So it has a very similar structure as the class that we saw before. However, we don't need to collect a particular object, so that's why we don't have this selection key attribute here. We still have this collection key because we are storing this the vote for each of the agents. The done event happens when all agents or a majority of agents agree that the condition is true. In this case, true means stop trading. So that's why we are emitting this skip trading event here. Negative event is the opposite, is when the agents agree that the condition is false. And the no majority event is when there's no majority between all the agents composing the service. And the known event happens when the majority of the votes, it's an abstain vote, in this case, is achieved by sending an empty value, like a non-value into the payload. And this is essentially this round. The final round that I would like to take a look at is this the generate round. As you can see, is completely empty because there's no body in this round, and these rounds are only used as placeholder points to connect the service, the ABCI app with another ABCI apps. So if you examine this, the ABCI app, like the finite state machine, which is in this case is the market manager ABCI app. It's one of the ABCI app that composes the trader. You can see that this is defined here. Let me see, final states. So here you have these two final states. This means that these states don't expect any transitions. You also can see here, like in the transition functions, they don't have any transition out from these states, because these states is just a placeholder where this FSM app will be connected to the next FSM app. And this is pretty much everything I wanted to show in this video. So thank you, and see you in the next video.